Good morning, everybody.
Good
We'll
morning, sir.
continue from where we stopped. Thank you. We'll continue from where we stopped. Please, we have discussed what's it called? Measurement in chemistry. We discussed that. We have understood the importance of significant figures in measurement. Okay. Though we also need to know the rules of rounding off. The rules of rounding off. So this will be done last to avoid confusion. So after this will be done last, don't forget. After this, we have to start now today, data analysis. This is today's work, data analysis. Data analysis, okay? All right. So who can help me out? What is a data? Can anybody help me? What is a data?
A piece of unprocessed information.
A data is a raw, unprocessed facts, I guess.
Raw facts.
You say raw. You say unprocessed. Those words are key. Now, a data is simply a piece of information gathered. You should now add, it may be raw or treated already. Data can be raw, can be treated. We have in mathematics, that's not what we are doing. I'm only trying to correct your raw and unprocessed so you can get it right. This is not our business. Raw or processed or not processed is not our business in chemistry. But just to give you a knowledge. Data can be primary data, which means unprocessed. For instance, you go to, you are doing a research. You are asked to determine number of students that get A's in FSC 112. Number of students that get A in FSC 112 and their age for the past 30 years in Unilag. Now, if you say for the past 30 years, that means you must consult something to get people that have gotten A before. What you are consulting to give information is a source of your data. And that source is a secondary source. That means somebody has collected the information before you are using it. Okay? If it's an information you collected on your own, and you get yourself through your own research effort, it is a word, primary data. You collect it yourself, and it's not used by anybody, it's not processed by anybody. You collect it raw. That's primary data. But let's read that one, that's what we're doing. All we have interest here is a data is a piece of collected information. That's what a data is here. Now, what do you mean by analysis of data? Can anybody help me? What do you mean by analysis of data? Anybody who can help me?
It can mean to sort data. Maybe according to a particular class.
Okay. To analyze a data means to do what? To study, to scrutinize data, to check for error, to check for irregularity in the data. For instance, people say that what? The age of students in 100 level are 16, 15, 18, 19, and you now see 101 years old. Somebody collected this data for you. 16 years old, 15 years old, 18 years old, 19 years old, 20 years old, 25 years old. But somebody now collected among his data, he put 101 year also. There's a need to pause and ask the data collector that how far this is all among the data you have collected. You now have to carry out, yes, that boy, meet yourself. You have to carry out some analysis to give reasons why this will be dropped. Okay? But in chemistry, the data we collect are data for an investigation you're carrying out on chemical processes. For instance, I've asked you to determine the density, the salt content of water in Lagos State. And I've asked two people, person A, person B, person A, person B, and they've come out with the following. Please, like I said, you have been asked to collect the salt content of all the rivers in Nigeria. And there are two people asked to do that. Here present 2.84 milligrams. He measured he got salt content for different, what's it called, rivers in Lagos or in Nigeria. He got 2.92 milligrams. He got 2.81 milligrams. For the same experiment, this person got 2.99 milligrams, got 3.48 milligrams, and got 7.25 milligrams. Now, and from literature, from the secondary data collected, it has been believed that the average salt content in every river in Nigeria, on the average, is 2.98 milligrams. This is what? A secondary source of data. Okay, an existing data from that somebody has recorded over the years. They have said the average salt content of all the rivers in Nigeria should not exceed 2.98 milligrams average, on the average. We now ask you to reconfirm this data. We now chose two people, and they came with these samples. A measured the salt content and got all this. B did the salt content and got this. We'll now subject these two people to data analysis. We subject this measurement to data analysis. We want to look at who among these two guys here is accurate. Who among these guys here is more precise. So in data analysis, we do two main things. We do accuracy and precision. These are what we are doing in data analysis. We are testing. In data analysis, we are testing for both accuracy of the data you have presented to us and the precision of the data you have presented to us. What is accuracy? Accuracy means closeness. Degree. Accuracy means degree of closeness. Degree of closeness of a data. What? Or mean of a set of data. Degree of closeness of a data. What? Let me show you. This is data 1. This is data 1. This is data 1. I'm comparing closeness of a data or mean of this data to the true value. To the true value. What is true value in this case? They have told us that the sort content of Nigeria can never exceed this from literature. From literature, they have recorded for us that the sort content of Nigeria cannot exceed it. So this becomes the true value. Here is the data. 2.84 is the data. 2.92 is data. Or this are data. They are data. The meaning of it will be compared with this, or individually compare with this. That is called accuracy. Degree of closeness of a data. How close is this to this? Or mean of a set of data. Find the mean of this. That's this plus this plus this. Find the mean. How close is the mean to this? Or how close is each of these to this? So the true value. That's called what? Accuracy. Now, what is more important between accuracy and precision in measurement? I'll get here. If I forget that question, please ask me. Please ask me later. Which of these is more important in data analysis? If I forget, please remind me. Now, what is precision? No, let's finish accuracy first. Let's not model it up. Accuracy of a data. Accuracy of a data. How accurate is the data you are presented? The accuracy of the data is measured in terms of one, absolute error. Two, relative error. Three, percentage relative error. Percentage relative error. Now, look at it. What do you call absolute error? Absolute error is usually, I'll erase this one. You have jotted it. I'll erase it. I can start with this one first. What do you call error? Let's even see. Can anybody tell me what an error is? What do you call error? Can anybody help me? What do you call error? Anybody? I don't want to call name. Who can tell me what an error is?
A mistake.
Error is a mistake. Is mistake truly the same thing as error? Fallacy. Okay. An error. Yeah, thank you. Please mute yourself. Thank you for the response. I appreciate that. Thank you. An error is simply a discrepancy between what you measure and what should be measured. It's not a mistake. Error is not a mistake. There are many things that can cause error. Errors are generally classified into two. We'll get here. Errors are either systematic error, not mistake, or random error. We shall get to this. Errors are either systematic or random. Errors are either committed because you lack knowledge or because conditions for measurement are not favorable, or because your equipment is giving you wrong value, or you yourself do not have knowledge of what you are measuring. That's where errors are classified. You have asked a carpenter to go and measure the temperature of human being. You have committed an error. Okay, because the carpenter does not have knowledge of temperature, of thermometer to measure temperature. We'll get here. What I'm saying is that error means discrepancy in measurement. So, what is absolute error? Absolute error means true value minus measured value. Or absolute error means measured value minus true value. Now, why is it C minus S or X minus C? Because you must not get negative answer. You must not get negative what? Answer. Whichever of these is bigger will come first. If T is bigger than X, or X is bigger than T, that will determine who comes first. That is the meaning of the word absolute. When you hear the word absolute, absolute means positive. Absolute values are positive values. So it's what? T minus X or X minus T. For instance, I've asked you to measure the length of this board. What class? Measure the length of this board. I called 3 students to measure the length of this board. Me, I know the length of the board as 3.2 meters. That's the length of my board. I know it. Since I bought the board, I know the length. And I ask you, measure the length of the board. You give me 2.8. Somebody give me 30.8. Instead of 3.2, that is the answer. Now, either of you have committed what error? Because this is the true value of my measurement. You have committed an error. Reason for your error. This is schematic error or random error, I don't know. But I know you have committed an error. What is the error committed now? Your absolute error is now what? What you should have measured and what you measure. That be 3.2 minus 2.8. You've committed 0.4 meter error. This person, I will not condemn this person. I don't know what caused the error. 30.8 was measured instead of this. In this case, it will be 3.2 minus 2.8 because this is bigger. This is true value. These are measured value, X. So I will say 3.2 minus 2.8. That's true value minus X, minus measured value. Or I will say what? In this case now, measured value is more than the true value. I will say 30.8 minus what? True value, 3.2. So if this is what you measure, I will say this minus true value. If this is what you measure, I will say true value minus 2.8. Summary, you are talking too much on this. The summary is that you must get positive answer. Either C minus S or S minus C. S can be single measurement and S can be mean of a set of measurements. We are getting there. Then we have what is called number 2, relative error. Relative error. What is relative error? It's actually absolute error. Absolute error. Which is it? Absolute error here. Over true value. Over true value. That means calculate the absolute error. Calculate the absolute error and divide by the true value. You will get what? You will get relative error. You will get relative error. You must take note of that. Now, we now have the last one, number 3. Percentage relative error.
Oh,
What's percentage relative error? It's just relative error. Relative error times 100%. Times what? Azizat. Dr. Adam Strange. Dr. Adam Strange. Dr. Adam Strange. You are disturbing. Adam Strange, you are disturbing the class. Azizat, mute yourself also. Azizat. Thank you. So, percentage relative error is what? Relative error times 100%. That means that what? All the formula are just all in one. Calculate absolute error. This is calculate relative error. That's what you get here over the true value. Then this one. Which of them, how do we determine accuracy here? How do we determine that, oh, this data is more accurate than this? When you have two sets of data, A and B, two sets of data, A and B, like these guys that presented this measurement. And I want to ask you, who is more accurate here? Is it A or B? Who can answer the question? Who is more accurate? Is it A or B?
A.
You can't be sure. Don't be too sure like it's A until you calculate the absolute error. You have to put it down now. The lower the absolute error, the lower relative error, the lower percentage relative error, the more the accuracy. The one that gives you lower value, the lower these values, the lower the absolute what? Error. Take note of that. Though the most used tool here is the percentage relative error. When the percentage relative error is very low, the lowest among all the sets of data, the one that is lower among all the sets of data is the most, of course, accurate. So the lower the percentage relative error, the lower the more the what? Accuracy. The more the accuracy. Let's go to precision.
I have a question.
Yes, please go ahead.
Okay, you said that accuracy is like when it's equivalence of a data to the true value. But
yes,
you said the lowest is the one with the least percentage relative error. But I thought it's supposed to be
okay.
You said the lowest value is I thought it's supposed to be the I thought it's supposed to be 2.99 because I think that's the closest to the true value.
No.
Oh, sorry, 2.92 rather.
Yeah, I understand you. I understand what you are saying. You are looking at the data. We have first noticed that girl. Notice that you cannot take measurement in isolation. Note that first. You can't take measurement in isolation. If you base it on that, then 2.99 is the most accurate figure. Data are not taken in isolation. Data are taken together. Therefore, you will not compare 2.84 to this. No. This is not a single measurement. This is a set of measurements. I said, well, or mean of a set of data. If it's a single data, you compare one to one. But if there are many, you must use the mean. So step one here, that girl, I don't know your name. Step one here for many data like this is what? Calculate the mean. Calculate the mean. Don't ever pick data in isolation. You take them together as one data. Good. Confirm to me what I said is clear.
It's clear, sir.
Good. God bless you. So you will not use this or this or this. No. Find the mean. Find the mean. And I compare the mean with this. That's why I call here S bar. I didn't call it what? S. I call it S bar. S bar. Because you usually have set of data, not a singular data. Good. So let me repeat this for the upteenth time. The lower the percentage relative error, the lower the relative error, the lower the absolute error, yeah, the more the accuracy. The more the accuracy. And don't pick data in isolation. Get the mean of data. Now, what's precision? What is precision? Precision is what? Is a measure. Is a measure. Is a measure of the degree of closeness of a set of data to each other. of a set of data towards each other, provided they are measured with the same instrument. You have to measure them with the same what? Instrument. Not that you will use meter rule to record this guy. You will not use, what's it called? Tape rule for this. Or you will not use a more precise equipment for this again. It must be the same equipment. We say precision is the what? Is a measure of the reproducibility of what? Your instrument or data. Reproducibility of your instrument or of your data. Meaning your instrument has the ability to reproduce what you have measured. I will explain what I mean. Too much grammar. To reproduce means to be able to produce what you have gotten before. For instance, I use ruler. I measure this length. I got 2.1. I use again. I find the what? The length. I got 2 points. Where? Let me now say a ruler, because what I need now, a ruler cannot do it. So I get 2.12 here, centimeter, by more words, technical equipment. Your meter rule cannot give you more than 0.1 centimeter having an accuracy. Meaning, you cannot tell me you measure something on a ruler. Watch you measure something using a ruler and you get 3.57. Note it now. Every instrument has the number of decimal places they can measure. A ruler cannot measure more than 0.1, one decimal place. You cannot say a ruler gave you this. It's wrong. They will mark it wrong from the table. Not all of it I want to manipulate secondary school. You manipulate reading. You want to drop your friend's reading. Your friend has gotten the following reading: 2.1, 2.3, 2.5, 2.9, 3.1. These are the reading of your friend in the lab work. You don't want to copy your friend, but you don't want your reading to be the same. You don't want your reading to be the same. You want to copy your friend. You now modify this result. You modify it as 2.08. It's not the same now. 2.31. You are trying to modify what your friend has gotten. 2.48 and so on. This person does not know how to draw. The man who will see this thing just cross this. Go cross hand. Why? A meter, your ruler, cannot measure to 2 decimal places. He knows, he's so sure you have dropped. A meter rule can only give reading to 1 decimal place. After points, you must have one number. So come back here. This person has measured the length of this board as 2.13, 2.11, 2.12 again. All these reading he got here, they are close. They are what? Close. The closeness of this reading to each other, the closeness, how close are these reading to each other, is called precision. It's called what? Precision. 2.84, 2.92, 2.81 are close. This is called precision. Closeness, degree of closeness of a set of data is called precision. These readings are not close to each other. If I ask you now, which of these is precise? Which of these A and B is precise? Anybody?
A.
A.
Which of these is precise?
A.
A.
Eh?
A.
Your answer should be, I don't know. Your answer should be, I don't know. You can't tell me who is more precise by looking at the data. No. Precision, right? Precision of data. Precision of data is measured, right? Accuracy is measured by this. See how to measure accuracy. See how to measure accuracy. You don't look at data and say, wow, this is more precise than this. Never. Don't do that. You'll be wrong. You can't look at this data and say, wow, these are close enough. This data is precise. No. Right. Precision of data is determined by, right, one, mean deviation. Mean deviation. Two, variance. Three, standard deviation. Standard deviation. Four. What's four? Help me now. Who knows another one? Who knows another one? We can use coefficient. Coefficient of variation. Coefficient of variation. We can use probable error. You can use probable error. Write it down also. Probable error. Probable error. Okay? Now, we have what is mean deviation? Let's start with, we'll leave this for now. We'll leave it for now. But it's correct. We have 1, 2, 3, 4, 5. Probable error. Even this one is not necessary for now. Okay? Now, what is mean deviation? Mean deviation is what? Summation x minus x bar over what? Over n. N is the total number of data. If I want to calculate the mean deviation for this guy now, what is my n? What is my n? 3. God bless you. If I want to calculate the mean deviation for this guy, my n is also what? 3. Now, my standard deviation is what? Is equals to square root of summation x minus x bar all squared over n. Over what? N. Provided n is greater than 25. This formula is only used if the number of data is greater than what? 25. It's also equals to square root of summation x minus x bar all squared over n minus 1. This one is used when n is less than or equals to 25. I want someone to help me. Which of these two will I use for this question? Which of them will I use?
The second one.
The second
standard deviation.
God bless your soul. God bless you. Why? Give me a reason. Why is this one? Why not this?
Because all the numbers are less than 5.
God bless you. The data is just 3. N is just 3. Whenever the data is not up to 25 in number, is not up to what? 25 in what? In number, we go for this. When the data is more than 25, we go for this. Tell me this is clear to you. Tell me this is clear to you.
It's clear, sir.
God
bless you. God
I have
bless
a
you.
question.
Yes, please go ahead.
Please, why are we not using that first formula? That means deviation.
This one?
Yes, sir.
Yeah. Mean deviation only tells you what mean deviation only tells you How far is your data from the mean? How far is your data from the mean? I will still explain it. Standard deviation gives you degree of deviation of your data from the mean. It shows by how much the data truly deviates from the mean, from the true value. I will explain to you. Watch, look at it. Before you even ask the question, I want to ask you first. I want to ask you. Firstly, note that girl, you can use this, you can use this. You can use mean deviation, you can use standard deviation to determine precision, to test for precision. So that was the question. Not only this you can use. It's not only this you can use. You can use this or this to determine what? Precision. Is that you confirm to me if I answer a question? Like go
Okay,
on.
yes, sir. But wait, I just want to ask you something. Like, in which manner do we have to use that mean derivation and this other thought formula? Like, what's the
Okay. You are doing what? You are doing OBJ exam, not theory. It's OBJ you are doing, not theory. So, what I ask you is, who between this and this is more precise? Who between this and this is more precise? And you can use this to test who is more precise. You can use this to test who is more precise. Easy answer, the girl.
yes, sir.
God
Thanks, sir.
bless you. God bless you. Yeah, let me now ask you my own question. Let me ask you my own question. Yeah, tell me, how do you know who is more precise? Is it more of this or less of this? Is it the higher the deviation, the more the precision, or the lower deviation, the less the precision? Whoa, anybody?
The higher
The
number,
iron.
the
The
higher
less
the mean
deviation, the more the
deviation,
precision.
the lower the number, the lower the standard
Okay,
deviation.
pick A or B. Pick A or B. Less deviation, more precise, more precise. B, more deviation. I mean, more deviation, more precise. Pick A or B.
A.
B.
A.
A.
If you are A, if you are
A.
A, raise your hand. If you are A, raise your hand. Do you know when you raise your hand? If you are A, raise your hand. Yeah, I can see Abdurrahman, Iri, Victor, Oli. I can see MUK. I can see MUK. He said A. That's nice. Who again? If it's okay for A, put your hand down. A, put your hand down. If it's B, raise your hand. Victor, Olajide, Salimon. Okay, others are not in the class. Yeah, let's go. Less deviation, more precise.
Ah, I think Gary.
Look at the board. Look at the board, class. The less deviation, the more your precision. Why? Let me ask you, who can tell me this? If somebody gave us this reading, first reading, 5, next reading, 5, next reading, 5, next reading, 5, next reading, 5. The person measured something 5 times and he recorded 5 times. What can you say about this person measurement? Anybody?
It's precise, but not accurate.
It's precise, it's accurate. It's precise, it's accurate. Let me ask you, what's the mean of 55555? What's the mean?
5.
5.
It's 5. It's 5. And most likely, tell me, what will be the true value? Most likely, anybody? It's 5. It's 5. It's 5. You can think got 5, 5, 5, 5. If you keep measuring, you will get 5, 5, 5, 5, 5. That is what reproducible. The values are constantly reproduced. Most likely, the true value will be 5. Let me ask you, what is this person's absolute error?
0.
0. There is no absolute error. What is the person's relative error?
0.
What's the percentage? What's the percentage relative error?
0.
0. What's the mean deviation of this person?
0.
Go and calculate it. You get 0. You get 0. What's the standard deviation of this person?
0.
0. It's precise and it's what? Accurate.
Accurate.
Precise and what? Accurate.
Accurate.
God bless you. God bless you. Now, look at it again. How many of you know the dartboard? Who knows dartboard? Dartboard.
Yes.
Yes.
Good.
Yes, sir.
Dartboard. The dart game. The
Yes,
dartboard
sir.
asks what? The dartboard asks what, class? What's your target in your dartboard? What's the target? Oh, the bull's eye. The bull's eye is your target. The bull's eye is your target. This is an exam question. When I'm done explaining the dartboard and the bull's eye using precision and accuracy, be rest assured you have gotten one exam question right. Now, look at this dartboard. What class? This is dartboard. And this is the bull's eye. That's the bull's eye. The target, what's the target of this person that throw the dart? What's target? Where's the aim? Where's the aim? It's aiming the bull's what? Eye. It's the aim the what? The bull's eye. Let's see the board. See the board. He threw the first one. Now here he lined. He threw second one. Now see here he lined. He threw third one. Now here he lined. He threw the next one. Now here he lined. Fifth one, he lined here. Tell me, is that person close to the bull's eye?
No.
No. The bull's eye is 5. Watch. The bull's eye is a measurement of 5. 5 is the bull's eye. Listen, the bull's eye, what you are meant to measure is 5. What you are supposed to measure is 5. When you hit the bull's eye, watch and listen. When you hit the bull's eye, they give you 5. You get 5. The measurement is 5. Pay attention. The measurement is what? 5. If you hit the bull's eye. But all the 5 throws you did, you got 1.1, 1.1, 1.2, 1.09, permit me, 1.11, 1, 2, 3, 4, 5. You never hit the bull's eye to get what? 5. But every time you throw it, you got 1.1, 1.1, 1.2, 1.09, 1.11. What can you say about what you got and what you should have gotten?
It's precise but not accurate.
Precise but
God
not
bless
accurate.
you. God bless you. This guy is precise, but not accurate. Was it Jassy? You have Jassy. Was it Jassy there? Your readings are close. They are not what you want. They are not what you want. Because the readings are reproducible, they are close. You say you are precise, but the readings are not what you want. They are not accurate. So this is what? Precise, not accurate. So this one, you throw the first one. You throw the first one, you land here. So the first one lands here. Second one lands here. Third one lands here. Fourth one lands here. The readings are close to this. The readings are, your blue eye is 5. Reading you got are 4.9. Very close to 5. The next, you got 4.7, close to 5. The next, you got 4.0, close to 5. You got 4.5, close to 5. But the readings are not close to each other. I mean, the readings are not close to each other. Readings are not close to each other. Here, the readings cluster here. See there. See the readings. The cluster here. The cluster. They are around each other. But the reading here, they are scattered. They are close. What? They are close to 5. They are close to 5, but they are far from each other. They are far from each other. What do you say you are now?
It's accurate,
It's
but
not
not
precise but
precise.
accurate.
You are accurate.
But
You
not
are
precise.
accurate, but because all of them are close to the bull's eye. They are all close to the bull's eye. So you are accurate, but what? Not precise. God bless you, that boy. God bless you. Look at this person again. This is the bull's eye. All the readings, they are here. The cluster here. They are all clustered here. They are all clustered here. What do you say about this?
Accurate and
Accurate
precise.
and precise.
That is, all the readings are close to each
They are
other.
both accurate.
And all the
They are
readings
both
are close.
accurate and they are
Accurate and
precise.
precise. Accurate and precise.
God bless you. God bless you. This is what? Accurate
And precise.
and precise. Accurate and precise. Because the readings are close to each other and they are all close to the bull's eye. They are all close to the bull's eye. Values are like 4.9, 4.8, 4.8, 4.9, 4.9. They are close to 5 and they are close to each other. Look at this person here. See this person. He threw the first one, now here he land. He threw next one, now here he land. Threw next one, now here he land. Threw next one, he land here. The next one, he land here. And this is the target. The bull's eye is the what? The bull's eye is the what?
Not precise and not
It's the
accurate.
target. Right,
The
and not
bull's
accurate.
eye is the target. This guy, what? This guy, all the
Neither
readings are
precise nor
far from each other. They are far from each other. That's one. Two, all the readings are not even close to the bull's eye. What do you say this guy is?
Neither
Not
They are not precise
accurate.
and it's not accurate.
neither accurate
No.
No precise.
nor precise. Please confirm to me that 1, 2, 3, 4 are clear to you. Confirm to me.
Okay, sir.
They are clear,
Yes,
sir.
Though there are more things like I've dropped what? I've dropped confidence level or interval. I've dropped probable error. I've dropped coefficient of duration. I've dropped them. When we start PQ, past question, I will teach you all this. Because for confidence level, I will need the student t-test table. I will need it. I will need the student t-test table. When I forward the materials to you, we'll treat all the ones I dropped intentionally. They are dropped intentionally. They will be treated with PQ and with your, what's it called? With PQ and with the table that will give to you. All I'm saying is that what? Keep calm and never panic. Never panic. Our next topic will be atomic masses. Atomic masses. That is our next topic. Atomic masses. But before that one, we'll stop the class here for today. But take this for me. Let's see how serious you guys are. How serious you guys are. Yeah, everybody, right? Assignment. 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 Right. Two students, A and B. Two students, A and B. Two students. Two students. Two students. A and B. Measure the salt content. Measured the salt content of 3 rivers or 3 oceans. That's the problem. 3 rivers or 3 oceans in Lagos State. In Lagos State. And the following data were presented. The following data were presented by both students. By both students. These are how questions are set on this topic. Were presented by both students. Right. Student A, student B. Student A, student B. Student A, 2.84, 2.92, 2.81.
It's not clear.
It's not clear. Please, can somebody confirm the board is clear?
It's clear, sir.
Network.
It
Okay, that
is
means your
clear.
It's clear, sir.
Okay, that means your network. Check your network, brother. Check. That's the problem with online class. You must have a 5G phone or minimum 4G phone and have a very good network. If MTN is the best network in your area, use MTN and so on. Student B gave us 2.99, 3.20, and 3.10. Sorry, and 2.98 and 2.98.
The second one is 3.80.
Yes, this is 2.99. This is 2.99. This is 3.20. This is 2.98. Right. If the true value is 3.08, if the true value is 3.08, the true value is 3.08. Determine one, absolute error of both students. Absolute error of both students. 2, relative error of both students. 3. Percentage relative error of both students. 4. Standard deviation of both students. 5. Mean deviation of both students. Call this one A, question A. Then B. Who is more accurate?
Please, I can't see the figures on the board.
Okay, I'm coming. 2. Who is more precise? 1. Who is more accurate? 2. Who is more precise? Who is more accurate? The figures that you are listening. The girl should listen. Are you with me?
Yes, sir.
2.84.
Sir?
2. I'm see the board, watch, see the board. That's my hand.
Okay.
Yeah, 2.84.
Okay, sir.
2.92.
Okay, sir.
2.81.
Okay, sir.
Then for B, 2.99, 3.20, 2.98.
Thank you, sir.
True value, 3.08. You're welcome. And this is milligram. We stop the class there for today. I hope you guys learned. I hope you learned.
Yes, sir.
All right.
Thanks,
Class
sir.
will stop there for today. If you
Oh,
have
yes, sir.
any GPED students, tell them to attend Ajetawo tutorials. We have both hostel. We offer tutorials. So tell them to attend, to join us.
Okay,
It's
sir.
a place everyone wants to be. Trust me. Thank you.
Sir,
Okay. Yes, I'm with you. Your
sir,
question.
you said that we should remind you of something. I didn't hear you clearly.
The difference between precision and accuracy.
No. I want to ask you, which is more important, accuracy or precision?
Accuracy.
Both.
Do you know
Precision.
you can do what? Precision is more important than accuracy in any laboratory work. What do I mean? Let me explain it to you. If you're asked to do experiments in laboratory and the value of G, you're asked to use your experimental work to determine the value of G. If all of you in that, G is 10 meters per second square,
Yes,
G
sir.
is 10 meters per second square. If all of you in that lab got G as 20 meters per second square, you see this one 20, that one 20, this one 20, that one 20, everybody 20, 20, 20. All of you are precise, but you are not accurate. Because G should be what? 10. Abina?
Yes.
The lecturer will never mark you wrong. It can be systematic error. In that case, precision has overridden the what? Everything. Because why will all students be getting this? There's something wrong, and it's not the fault of these students. Precision is more important. Have you heard where people will go to lab? When they go to lab, they will say, this person has this sickness, God forbid, because the reading is showing 1.5 and it should be 3.0, but it's showing 1.5. The man will go to another hospital. They will do the thing again. He got 1.5. It should be what? 3 point something. He go again to another place. 1.5. It should be 3 point something. The code you're reading are in the range of 1.5, 1.5, 1.5, 1.5. Person should accept the result because there's precision in all this lab. Do you get me?
Yes, sir.
Precision overrides accuracy in measurement. Have a good
So when is our
afternoon.
next class?